VLSos here. This is a video lesson for geometry on tangent. Tangent is a relationship between an angle and two sides of a right triangle. Specifically, the tangent of an angle in a right triangle is equal to the ratio of the side opposite divided by the side adjacent to the angle. And like the Pythagorean theorem, tangent only works for right triangles. We have a right triangle here. We have an angle in the right triangle other than the right angle. And we have two sides labeled x and 10. We know the measure of one but not the other. We can use tangent to find the unknown x. We start with the mathematical relationship. The tangent of an angle in a right triangle is equal to the side opposite divided by the side adjacent to the angle. And I've abbreviated opposite and adjacent here. Now we're going to fill in this equation with what we know of our right triangle. We're going to take the tangent of this 30-degree angle. The side opposite this 30-degree angle is x. So for the opposite, we substitute x. And we're going to divide by the side adjacent to the 30-degree angle, which is 10. Adjacent means next to, and the hypotenuse, which is unlabeled, is next to the 30-degree angle, but it's the hypotenuse. So we don't consider the hypotenuse to also be adjacent. Whenever we consider an angle in a right triangle, there are two sides that are next to that angle, but only one is adjacent because the other will be the hypotenuse. The adjacent side to 30 degrees is this 10 here. When we substitute the values in, we have created an equation with one unknown, which means that we can solve for this unknown x and get its measure. I'm going to do that before I go to a calculator. I'm going to multiply both sides by 10 to get x by itself. When I do, I'll multiply the left side by 10 and show it as 10 times the tangent of 30 degrees is equal to x. Now x is by itself. I'm going to go to a calculator to evaluate this. This is going to be 10 times the tangent of 30 degrees. It's important to note that we're not multiplying something called tangent by 30 degrees. Tangent is a function in itself. And that function, the calculator has a key for it right there, labeled tangent. Most calculators will have a tangent function key to use. So to use this calculator, I need to enter the angle first, 30 degrees. My calculator I'm checking is in degree mode. And I take the tangent of it. And it gives me the approximation of the tangent of 30 degrees. I'm also going to multiply by 10. So 10 times the tangent of 30 degrees is approximately 5.774 if I round to the nearest thousandth or third decimal place, which is the best habit to be in. What does this mean? I have found an approximation for x. I was able to begin with an angle and a side of a right triangle and use tangent to find another side. Let's get more practice with this. Triangle, side of y, side of 10, and 40 degrees. Can we find y? Well, if we're going to, we could consider using tangent. We wouldn't use the Pythagorean theorem because the Pythagorean theorem would involve three sides, and we don't know two of those sides, so it wouldn't be useful to find any one of them. If we use tangent, then we're going to begin, tangent of an angle is equal to opposite over adjacent. And we're reminding ourselves that if we're going to use tangent, it needs to be a right triangle. It kind of looks like this is a right triangle because it's drawn on graph paper, but that would be an assumption. We should say we cannot use tangent because we don't know if this is a right triangle. Maybe the problem would give us this angle so that we wouldn't have to guess. So if we know that this is a right triangle, we can try to apply tangent. Let's do that. I'm going to use this angle here. The tangent of 40 degrees is equal to the side opposite, which is y, divided by the side adjacent. Now the side that is adjacent to this 40-degree angle is this one here that's unlabeled. I cannot use this measure of 10 to be adjacent, the adjacent side, because that's the hypotenuse. How do we know? The hypotenuse in a right triangle is always opposite the right angle. And the hypotenuse is in a right triangle is called the hypotenuse. It's never the opposite and it's never the adjacent side. That means that we don't know the opposite or the adjacent side. We have tried to use tangent, and in doing so, we create an equation with two unknowns, which means that we can't solve for any one of the unknowns. Tangent is not going to help in this case. It's the purpose of this example is to try to use tangent and know when we can't. Let's give another example. Here we have a right triangle. We have a side of x and a side of 10, an angle of 55 degrees and an angle of 35 degrees. Can we use tangent to find the missing leg x in this right triangle? Well, we could try. We start with tangent before using it. Tangent of an angle in a right triangle is equal to opposite over adjacent. Now I'm going to plug in information from the triangle. I'm going to take the tangent of an angle, but here I've got a choice. There are two angles to use. We never use the right angle when we use tangent. We're always going to use one of the other acute angles in the triangle. But we have both of them labeled. Does it matter? Well, I'm going to select 55. The tangent of 55 degrees will be equal to the side opposite that angle of 55 degrees, which is the x, divided by the side adjacent to 55 degrees, which is never the hypotenuse here. It's going to be this 10 that's adjacent. This sets up the tangent equation with one unknown. We could certainly solve this for x. But what if we made the other choice? What if, when setting up the tangent equation, I chose this 35-degree angle? So I'm going to proceed. The tangent of 35 degrees will be equal to opposite over adjacent. But what's opposite the 35 degrees is the 10. It's not the same as what is opposite 55. And when we divide by the side adjacent to 35, it's going to be x. So my setup is a little bit different, but it's done correctly. And I created an equation with one unknown x. I could use it to solve for x. In other words, I've set up tangent two different ways because I had two different angles. Either way will work. Some might feel that it's easier to work the equation the first way that we set it up because all I have to do to get x by itself is multiply both sides by 10. And that is certainly a more direct way to get x by itself. But let's proceed to find x. In this case, I'm going to take this first equation and I'm going to continue my work here. I'm going to multiply both sides by 10. 10 times the tangent of 55 degrees will be equal to, now x will be by itself. If we multiply by 10, it'll undo this division by 10, leaving x by itself. And now I'm going to go to a calculator. This is going to be 10 times the tangent of 55 degrees. Remember, tan 55 does not mean you're multiplying. Tangent is a function in itself. So this is going to, I'm going to first take the tangent of 55 degrees. My calculator is in degree mode. 55 is the angle. I press the tangent key to take the tangent of it. I get this decimal approximation. I'm also going to multiply by 10. And I get x is approximately 14.281. Great. That worked. I found the side measure. It's approximately 14.281. But what if I had set up the equation, the second one? Would I get the same answer? Well, let's see. In this case, what I'm going to do is I'm going to take the tangent of 35 degrees first. I'm going to get an approximation with my calculator, 35, hit the tangent key. The tangent of 35 degrees is approximately 0.700. And that's going to be approximately equal, because I'm working this line here. I've just taken the tangent of 35 degrees, but it's still equal to 10 over x. Still need to find x by itself. To do that, I'm going to multiply both sides by x. And then to get x by itself, I'm going to divide both sides by 0.7. So x will be approximately equal to 10 divided by 0.7. We'll go to a calculator. And I get approximately 14.286. Are these answers different? Not, well, they are as we wrote them down as approximations, but it's the same value. The difference here is that I approximated early here. And by the time I took a step, then I was a little bit off my first answer. Both of these setups of tangent will work to find x. The first one may be easier because a step is saved. But also this highlights working with approximations and being careful to be as accurate as you can. When you are using tangent on a calculator, you will often be getting approximations. So the best thing to do in order to be as accurate as possible in the end, both of these answers are accurate to 2 decimal places, 14.28 and 14.28. It's very important when you work with tangent yourself to write several decimal places of accuracy as you go along.